Good morning, everyone. Next is the Avl Tree rotations. So why we go for a rotations when the Avl Tree is making unbalance? So that time we are using some rotations to convert the unbalanced root to balanced root. So the rotation is the process of moving nodes either left or right to make a tree is balanced one. So this have mainly it can be divided into two types, that is a single rotation and then double rotation. So in that single rotation we have further categorized into two types, that means a left rotation and then right rotation. So it only take only one step, that's why it is called as a single rotation. Either it will be a left or right. So in that double rotations, in that it have the combination of single rotations is called as a double rotation. Either it is a left and right combination or right or left combination. So both are mixed together. This is the avial tree rotations. By using this rotations only, we help make the tree is a balanced. So the next one is a single left rotation. This is also called as LL rotations. So in that, when inserting the element 3, 2, 1, it look like as a left skewed tree, which makes the balance factor is a 0, 1, 2. Okay, when we got more than the values minus 1, 0, plus 1, so that tree is called as a unbalanced because the node 3 have balance factor is 2. So now I want to make a balanced row. So I am using single left rotation. I am just rotating, shifting the elements and rotating the third node. The third element node is shifted into the right side of the node 2. Okay, so then the balance factor of each node, everything is a 0. So this time after the left rotation, so the tree is a balanced one. So next one is a single right rotation. It is also called as a RR rotations. So in that rotation, so when you are inserting the ascending order elements, which means 1, 2, 3, we got a minus 2, minus 1, 0 are the balance factors. So in which I am using the RR rotations, in that just the left, the first element is should be moved to the left side of the root node. Now the root node is a 2. So now the balance factor is 0 for all the 3 nodes. The next is left right rotations. So in that, so the tree, it should be a combination of both left and right rotations. So when the condition, when the tree is imbalanced like this, the first step, okay, so the look like unbalanced tree is look like the first one. So when we got the tree like this, I am using first the RR rotations to moving the second element to the right side. So after converting this one, after taking the left rotations, so it will be a make a perfect balanced one. So after right left rotation, this is the final one when we got the tree like this at the first state. So like this, we are just moving the second element into the right side and the third element is next to moving to the left right side. So now we got a 1, 2, 3. It look like in the or rotations, singular rotations. When we are applying the singular rotations, we got the unbalanced it. So this is the one example. So this is the construction of AVL tree by using the element from 1 to 8 digital numbers. So digital numbers. So in that first step, insert 1 the balance factor. The first node should not have any left or right side. So the balance factor is a 0. So the next one is a 2. When in inserting 2, I am just comparing that 2 with the root node. So it should be a higher than, so it should be a moved to right side. It should be occupy the space of right side of a root node. So when computing the balance factor, so it should be a 0 for 2 and then 1 minus 1 for 1. So this is also tree is a balanced one. So when next time inserting the third element, it look like a right skewed tree. So in that condition, we must apply some rotations because of we got a balance factor is -2 at the first root node. So absolutely we must use the rotations to make a balanced one. So this is I am using the aura rotations in that. So we got the final. So the next while I'm inserting the 4, so we are just moving the right side of third element. So after computing the balance factor, so the balance factor is absolutely between the -1 to +1. So that's the tree is a balanced one. Next I want to move on the next step. In the fifth step, I am just inserting the fifth element. So while I'm inserting the fifth element, it at the right side of the root node, it is skewed tree. It will make a skewed tree, and also it make a unbalanced one. So that's why I go for the last three nodes, which are the direction of inserting inserted direction. So which element got a -2 or +2 anything. So from that I am taking this three nodes, next three nodes. So after taking the rotations, it make a balanced one. So next one, inserting 6, it is also creating imbalanced one. In that time I am just converting LL rotations, so it will make a tree is a balanced one. So after inserting 7, it also is a tree imbalanced. In that time I am using the RR rotations. So in that we got a final. So after inserting 8, it does not affect the balance factor of any nodes, which means the uh, given balance factor. So that means it's not above the -1 and +1. So now the tree is a balanced one. So the same way the deletion of Avl tree also will be do in the same manner. When you are deleting an element from my Avl tree, so after deleting the element, if the tree is a balanced one, we can't do anything, that will be taken as a final tree. Otherwise, if that balance factor is above the -1 or +1, so it should be take rotations to make a balanced one. The same way will be happen in the deletion operations also. So at end of things, so we mind some things, that means after inserting the element and then after deleting element, whatever the operations will be doing on the same AVL tree. So after got the result, you must check, so you must check whether the tree is a balanced one or unbalanced one. If you are checking the same way, you didn't get any error, any mistakes in unknowingly happened. So this way is used to learn to make a AVL tree in more easier way. So thank you.